Here is another type of center of pressure question from past MMD papers. This is a bulkhead, which is a combination of a rectangle on top and an isosceles triangle at the bottom. Transverse bulkhead consists of a rectangle of breadth 18 meters and height 12 meters, and below it an isosceles triangle of breadth 18 meters and height 9 meters. If the adjacent tank is filled with oil of RD 0.92 to a head of 2.8 meters, calculate the thrust and COP of the bulkhead. So here is a drawing. This is a rectangle. Breadth of the rectangle given is 18 meters. 18 meters is the breadth of the rectangle, and the height of the rectangle is 12 meters. This is the top of the bulkhead, tank top. We have an isosceles triangle below the rectangle. This is the isosceles triangle. The depth of the triangle is 9 meters. Breadth is the same as the rectangle because it is just below the rectangle. So here we have to do two things. First, we must find to find the center of pressure of this bulkhead, which is comprising of two different type of shapes. One is a rectangle and one is a triangle. We must first find the centroid of the bulkhead, and then we must find the moment of inertia of the rectangle portion about water surface. Then we find the moment of inertia of the triangular portion about water surface. We will add them up, and that will give us the moment of inertia of the entire bulkhead about water surface. So two things to do. First, we find the centroid of this bulkhead, as that will be usual. We'll take moments from tank top, and then we'll find moment of inertia individually of the rectangle and triangle about water surface, add them up, and that will give us the moment of inertia of the complete bulkhead. And then the center of pressure can be found easily. So here is a diagram that we have been given that the oil has been filled in the adjacent tank to a head of 2.8 meters. So the liquid level is 2.8 meters above the tank top, because it's a head of 2.8 meters. Okay. Now, what is the centroid of this rectangle? Centroid of a rectangle is always half of the height. It's halfway from this side and halfway from the other side. So G2 is marking the centroid of the rectangle. So the height of the rectangle is 12 meters. So centroid will be half, 6 meters from tank top. Concerned, the centroid of the triangle will be one third of the height of the triangle from the base. So height of the triangle is 9 meters. So one third of 9 is 3 meters from the base. But we will be taking moments about tank top. So the centroid, depth of the centroid of the triangle from tank top will be 3 plus 12, 15 meters, because moments will be taken from tank top. So let's proceed. As I said, let's first find the centroid of the bulkhead, GC. So G2 is the centroid of the rectangle, G1 is the centroid of the triangle, and G will be the centroid of the bulkhead. And below the centroid of the bulkhead, there will be center of pressure P. So let's find G, the centroid of the entire bulkhead. So I'm taking moments about tank top. So the area of rectangle, which is 12 by 18, multiplied by the distance of the centroid from the tank top, which is 6 meters, centroid of the rectangle. So plus, we are taking moments of the triangle now. So area of the triangle, half base into height. Base is 18, height is 9. So half base into height is the area of the triangle multiplied by distance of its geometric center from tank top, because moments are being taken from tank top. So the distance of the centroid of the triangle from tank top will be 3. 3 is from the base and plus another 12 meter, 15 meter. So moments of the areas are area multiplied by distance of its centroid from the axis about which we are taking the moments. So 12 by 18 into 6 is the moment of the rectangle about tank top. Then 18 by 9 divided by 2 into 15. This is the moment of the triangle about tank tops. So total moments, we add them, divide by total area. So area of the rectangle again 12 by 18 and area of the triangle half base into height 18 into 9 upon 2. So I get the geometric center of the bulkhead is 8.454 meter below tank top, because we took moments below tank top. So this depth of 8.45 meter, 4 meter is also from tank top. Total moment upon total area. So what will be the centroid of bulkhead below water surface? So there is a 2.8 meter head above the tank top. So 8.454 meter is from tank top plus 2.8 meter, which is the liquid column above the tank top. Total 11.254 meter is the depth of the centroid of the bulkhead from water surface. Now 11.254. Now I proceed ahead to find the moment of inertia of rectangle. So moment of inertia of the rectangle about water surface, WS, will be, first I have to find moment of inertia of this rectangle about the axis which is passing through its centroid. Then I add area of the rectangle immersed below the water, A, multiplied by the depth of the centroid of the rectangle from water surface, because we are taking the we are finding the moment of inertia about water surface. D is always the distance between the two axes. One axis is passing through centroid and the second axis is at the water level. So distance between the two, that is the depth of the centroid below water surface. D, square of that. So rectangle, as you know, LB cube upon 12. So here in this case it will be B as cube breadth multiplied by cube of the height of the rectangle upon 12 plus area of the rectangle is B breadth into height and D square. So put the values here. Breadth of the rectangle is 18 meter, height is 12, so 18 into 12 cube upon 12 plus rectangle area is 18 by 12, and what is the depth of the centroid of the rectangle from the water surface. So it is 6 meters below the tank top. Water surface is 2.8 meters above the tank top. So from water surface it will be 6 plus 2.8. 8.8 meters. The D will be 8.8 meters. So I get 19319.04 meter as above. This is the moment of inertia of the rectangular portion of the bulkhead about water surface. Similarly, we find the moment of inertia of the triangular portion about water surface. So what's the moment of inertia of a triangle about the axis passing through its centroid? That's BD cube upon 36. B is the breadth of the base of the triangle, base of the triangle, and the D is the depth of the triangle. BD cube upon 36 plus A is the area of the triangle and D is the distance of its centroid from water surface. So 18 is the base into 9 cube, which is the depth of the triangle, because the complete triangular portion is also immersed below the water. So we take the complete breadth, complete base, and the height of the triangle upon 36 plus area of the triangle, which is immersed, is 81, and the depth of the centroid of the triangle from water surface. The center of the triangle we found is 3 meters from the base of the triangle. Then we have 12 meter is the rectangle above it, and then we have another 2.8 meter up to the water surface. So 2.8 plus 12 plus 3. This is the depth of the centroid of the triangular portion below the water surface. So I am finding the moment of inertia of this triangle about water surface. So it will be 2.8 plus 12 plus 3. That will be 17.8 meters square, d square. So I get 26028.54. This is the moment of inertia of the triangle about water surface. What's the total moment of inertia of the bulkhead? I of the rectangle about water surface plus I of the triangle about water surface. So that's we add the two and you get 45347.58 meters is to the power 4. This is now the moment of inertia of the entire bulkhead about the axis which is passing through the water surface, IWS. So what will be the center of pressure from water surface? The depth of center of pressure below water surface. Moment of inertia about water surface upon total area immersed multiplied by the D, which is the depth of the centroid of the bulkhead below the water surface. So IWS we found here. This is the one 45347.58. Total area of the bulkhead is the area of rectangle plus area of the triangle is 297, and we just found the depth of the centroid of the rectangle below the water surface, 11.254. This gives me center of pressure below water surface. Depth of the center of pressure below the water surface as 13.567, and center of pressure from tank top, we just subtract the column of liquid which is above the tank top, minus 2.8, 13.567 is from water surface. See, if I subtract 2.8 meter which is in the sounding pipe, I will get 10.767 meter is the depth of the center of pressure below the tank top of the tank, top of the tank. Total thrust on the bulkhead will be pressure multiplied by total area. Pressure is always calculated at the centroid. So the density of the oil is 0.92 RD of the oil, which is also the density in tons per cubic meter, multiplied by D is the depth of the centroid of the bulkhead below water surface, 11.254 meter. Total area of the bulkhead, 297 meters square. and this gives 3075.04 tons thrust, which is acting at the center of pressure. Total thrust acting at the center of pressure. Okay, that's all. That was how it is worked out. If there is a combination of the two shapes, it can be any shape. Can be. There is also a question where the triangle has been given on top of the rectangle. The rectangle is below. So no change, no difference at all. The working remains the same. First find the centroid of the bulkhead, taking moments from the top. Then find the moment of inertia of the each shape, each portion of the bulkhead from water surface, about water surface. Add them up, and that gives you the total moment of inertia about water surface. And then the standard formula for center of pressure and the thrust. There's one more question I just picked up. That's a concept clearing question. It's actually a bulkhead is in the form of a triangle, inverted triangle with apex downward.